All right. Hello, everyone. We are Project CARMLS, the cart for assistive return using machine learning and scanning. And this is our final design review. Here's what we're going to cover in our presentation today. A little introduction, our project background, what we actually implemented, our results, our future work, impact of coronavirus, codes and standards, cost analysis, and ethical considerations. Here's our team. I'm John Matreska. I'm the team leader and the hardware lead, and my interests are in electronics and power.
Hi everyone, I'm Jason No. I'm part of the software team of this project, and my interests include enterprise technology and programming.
I'm Frank. I'm part of the software team as well. My interests include software development and machine learning.
So our project motivation came from a meeting with the Young Adult Institute, YAI, and they assist people with mental disabilities to find and maintain jobs. So they told us about their issues that they had, that they saw in the workplace, and where the people that they support typically work. So an overview of our project, it's essentially a scanner and microcontroller that coordinate barcode identities with our database for sorting the items along a predetermined route. So you scan the item barcode is taken, sorted in our database, and then the UI shows the user where to return the item. And the social impact of this, we aim to improve the quality of life for people with mental disabilities at work, and allow them to have more opportunities to get these jobs.
So these are some of the related works that gave inspiration to our project. Project Bright Life was another Capstone project that worked on an inventory layout as well. Next, we have a research paper about decision tree integration with the database. And as for the last related work, a smart cart was also been working on in a Canadian supermarket that also implements machine learning and has a touchscreen interface.
So here's our project selection, AHP. We went through all of the components that would make up our project and decided these would be the four most important ones. And underneath are the applicable areas that we had to essentially choose from for our optimal design. These are the most important engineering and marketing requirements. And here's the matrix of how they compare with each other. So essentially, if you want better efficiency, you're going to have to spend more money on microcontrollers, but we're all right with that. And for the related theory, working with the hardware, I use circuit theory that we learned in school in power electronics, referencing a book by Ron Lenk to understand the equipment a little bit better.
For the software theory, Gini impurity and information gain were used. The Gini impurity determines similarities within the last column of the database, which is considered the label. And the information gain is how much information attributes within the database provide. And this helps place items better within the decision tree.
So here's our system architecture. There are 5 big points to work on. We have the scanner that sends the information to the microcontroller, the power supply that powers the microcontroller, the display that shows the user what we want them to see, and the database where we reference our input barcodes.
All right, here we describe the overall system architecture of the software side of CARMLS. We are utilizing Python code to communicate with our MySQL database. So initially, the code will send a request to connect to our locally saved database server. Then once MySQL is connected, we then create a connection cursor that allows to implement a SQL query within our code to further communicate with our MySQL database. Any code being executed from Python to MySQL is then carried out by the cursor execute function shown there. Once the information is executed to MySQL, we can then receive whatever information or data we need to output or configure within our database API.
So for hardware, the main components that we were working with were the One Nice USB scanner, the Sunfounder Raspberry Pi 10-inch touchscreen, the Raspberry Pi 4 for our microcontroller, and the buck power supply with a maximum integrated DC to DC converter. So on the left is the power supply design. We need a 5-volt 2-amp output for our microcontroller. And on the right is the actual implemented circuit. I just added the yellow on-off button that you can see in the middle to turn it on and off.
So moving on to the software side of this project, as stated previously, we're using MySQL to hold our database, and we're using Python to create the GUI, as well as the machine learning algorithm, the sorting algorithm that will be explained more in depth by Frank in the next few slides. So the database will consist of 4 tables listed there named items, user input, test, and employee. The tables will contain information such as item barcodes, the item names associated with their barcodes, as well as the aisle location and the shelf location of each item. The employee table will hold employee IDs as well as the associated names with the IDs. And as shown there, Python is being used because it offers tools to allow us to develop MySQL implementation and developing for our GUI. The 2 tools shown there that we use for our code is MySQL.connector that allows us to connect to MySQL database with Python, as well as tkinter, and that allows us to develop the GUI of this project. So here is the flowchart of the GUI. So first, there's a welcome frame that allows the user to access CARMLS. Next, there is a login frame where the employee would then scan his or her ID. And if the ID doesn't match with our employee database, then the user won't be able to log in. So once the employee is able to successfully log in, they are then met with the scanning frame, which is where they're going to start scanning their items to return. And once the user or the employee scans all the items needed to be returned, they can then press this one button that will then feed the machine learning sorting algorithm the user input. And then lastly, the output will then be shown to the scanning frame, so the user can know where the items will be placed and returned inside the workplace that they're in.
So this is a basic representation of how a decision tree works. It's a supervised machine learning method, which is used for classification. And as you can see on the right, it uses a branching method to illustrate possible outcomes. At the top, you can see the root node, which asks the original question, and then branches into internal nodes, which end up leading to leaf nodes. This is a flowchart for the machine learning algorithm. The first step is to access the MySQL database. This is important as this is where the database is actually stored, and the machine learning needs to access this in order to continue. Next, the number of each example will be tracked with an initial question will be established. The Gini index and information gain are then established, and this will help other functions in the database work more efficiently depending on their value. Once all this has been established, we can begin to move the tree and actually build it. And this will also create a separate print function to help display actually how the tree functions. And then once this is all done, a prediction will be created showing where the items are located in the store. So this is the first step, which is accessing the database. If you look on the right, you can see that this is the inventory. So this is like the made up inventory that we made for a store. It contains the item name, the aisle, shelf location, and the UPCs. And if you look at the left side, very at the bottom, you can see where it says barcode. So this is where the user input would be placed. So when a barcode is scanned with the scanner, it'll store the barcodes there and then match them to the UPCs that are seen in the table on the right. And then once this is done, it'll move over to the test database, which you can see on the next slide. So if you look at the bottom left, you could see, again, it says shelf, aisle, and item name, which match the shelf, aisle, and item name on the right. So the UPC is dropped out of this because it does cause confusion in the machine learning as it's such a large number. So whatever's matched will be stored here. And then the reason that they are clear right now and there's nothing in them is because after the machine learning runs, the databases get cleared except for the items one that contains the actual inventory. So this is the count function. Basically, the count function determines how many elements are in the last column. So this last column is considered the label, and this function will keep track of how many repeat and how many there are individually. Next, we need to establish a question. So this question will compare a feature value that's selected previously to a feature value that's selected in the actual question. And it'll ask if it's numeric and if it's greater than or equal to the actual value that's selected to determine where it needs to be placed. And then it'll also ask if it's equal depending on if it is numeric or isn't. So next we'll look at the Gini impurity again. So this will determine the probability that an item is mismatched and dictates how the items will be distributed within the decision tree. So this ranges on a scale from 0 to 1, 0 being the best, 1 being the worst. If you have some mixing, it'll be a decimal place in between the two values. And closer to 1 isn't what we really want. We want it to be as close to 0 as possible. So this is the information gain. It uses the previous defined function, the Gini impurity, to help define it, and it determines how much information certain attributes can provide to the actual database. So next we need to build a tree. So if you look below, you can see that there's some pseudocode that explains how it works. So basically, if the information gain is 0, it'll return a leaf. And using previously defined functions, the true rows will be selected and then we'll create a true branch. And then the false rows that are selected will create a false branch. And then through this, it'll also re-ask the question function, and it'll return whatever the best question is to ask for the possible database that's selected depending on the user input, and it'll return the true branches and false branches for the user input. And if you look here, you can see an actual decision tree that's created within Python using the print that we've created for the decision tree. So you can see at the top for this scan, it asks the initial question, which is the IO greater than or equal to 9. And if that's true, it'll predict that the item is fabric softener and it's located, and there's 2 of them. And if it's false, it'll continue to move down, asking another question, and it'll follow that. So now we're on to the prediction. The prediction is the last thing that happens within machine learning, and it'll calculate what the actual item is it's looking for, and then the predicted one. And as you can see here, there's 5 items, and each were predicted with 100% accuracy.
So our risk analysis for a product, basically we have this product in a work environment, therefore it has to be safe for the employees to work with. We also are incorporating a database, so we don't want that to be accessible to third parties. In general, just having them know your information or being able to change stuff in our database is not ideal. We also had to accommodate a member leaving the group in that association. So on our testing, we had 2 unit tests for the hardware, the voltage precision test and the power efficiency test. Here are the results. The voltage precision came up pretty well. There was very little voltage fluctuation, which was ideal. The power efficiency ended kind of poorly, damaging the power supply, but we found that it was most efficient at 12-volt input with a 93% efficiency.
So for the software unit testing, we've conducted a sorting efficiency test to see how accurate the algorithm is when fed a large amount of information. So the first step was to scan 50 items, and the second step was to scan 100 items. Overall, the algorithm is still able to efficiently sort the inputs with 100% accuracy per each step. And also to note, when being fed the information and having it sorted out, the algorithm sorts each step, the 50 and 100 items, almost instantaneously. So regarding the future work regarding CARMLS, we'd like to implement a 3D printed case to house all the hardware and software modules together. We'd also like to implement an LED light indicator system to further make the return system much more streamlined for any user that uses our product. Lastly, we'd like to have full integration with Linux since it's open source and it allows for scalability. Throughout the course of this project, regarding the software side, we've been using Windows for software development. For challenges that we've overcome and lessons learned, we've learned a lot about MySQL database integration. It's a very powerful database management system, as well as further development with Python, as that's a very coding language and is implemented widely in a lot of software nowadays. With that comes with some issues since the machine learning algorithm communicates with the database. So if one bad iteration happens with the code, cause a lot of issues for a lot of other parts of the software. And moving on to the hardware side of this.
Yeah, this was my first experience using soldering paste. The connections on the chip that we were using were actually too small to solder properly. So again, first time using solder paste. The equipment power ratings were also another challenge. Again, like I said in that last test, some of the discrete components weren't properly rated for the kind of current that I was testing it with. So that was a little lesson learned.
So after we had to switch to remote classes, we weren't able to meet as much due to different schedules being at home and with classes, and we continued with whatever parts we did had and implemented as much as we could. And this is the total cost breakdown and bill of materials. So as you can see at the bottom, we did maintain a budget and we did stay underneath that budget at only $301.
Here's the list of our code standard constraints. We've adhered to the IEEE Code of Ethics and made sure that our work is as transparent as possible. And to also make sure that we keep in mind of those that will be using our product within the workforce. We've used UPC-A codes, barcodes that are the 12 numbered barcodes on most of the products that we know today, and we've implemented that for the database. We have also used MySQL Workbench 8.0 and the latest version of Python, which is 3.8. Some ethical issues considered with regarding to this project. We wanted to make sure that we were creating an assistive technology inclined for the mentally handicapped and to ensure that our product will lead to good results that will benefit others and the work that it's designed to do. And here is a video demonstration of the GUI and the machine learning algorithm. So that's the welcome screen. User will then click continue. This is the login screen. I put in an incorrect ID just to show that it won't move on to the next part until you input a correct ID. Put in nothing, then it'll still continue to ask to input a correct ID. Here, I'll log in with my ID credentials, and then it'll move on to the scanning frame. So towards the bottom left there, you can see the user can start scanning their items. So I will pull in UPC barcode information from our MySQL database by simply copy and pasting. And then user will click next item, and that will store inside that little text box towards the top left to show you all the scanned UPCs. So I will scan 5 items there. And then the user would then click sort to have the information fed through the machine learning algorithm. And the output is shown towards the top right there. And the output is taken from the machine learning algorithm that I will show within the Python terminal there. So that is the machine learning algorithms outputted towards the terminal, and I was able to pull some information from that output to the GUI so the user can know where to place the items.
And here are references. Are there any questions?
Okay, hi guys, excellent work, very nice. I have a question. What type of machine learning technique did you use?
Excuse me?
What approach of machine learning did you use?
So we used the decision tree using like the CART method for the decision tree.
And what was the motivation of using the decision tree?
Well, I'm interested in machine learning, and we thought that it would be a better idea to use a decision tree to like further sort the items that are scanned to make it more efficient.
what is your set of data? How computationally effective is the technique using the decision tree?
What do you mean by that? Like how the scan like works through the decision tree, like
How
how effective it is?
cost effectiveness in time to use this technique in a relationship with the number of your data, with the volume of your data.
So when Jason performed the test, it worked almost instantaneously up to 100 items that were scanned.
100 items, okay? And how many? That is the reason you have 100 items. What is the dimensions of your population?
So this is meant for returning purposes. So they would be like filling a cart with items that would need to be returned. So this would only be for around like 100 items.
So you can use it if you decide to use it without machine learning technique due to the small size of population. Can you do it? Because I see there is very small sample of population. Can you do it without machine learning?
The item should be able to be sorted without machine learning, but if it was used on a larger scale, the machine learning would make it more effective and efficient.
In which sense?
That it would process the data faster and sort it faster.
Well, the question that I ask you, what kind of dimensions do you have? How many, the dimensionality of your data?
So there's only
You
3
have-
columns that are taken into the machine learning. There's the item name, the aisle, and the shelf.
Okay, so this is a technique that can be used by different approaches. What I would like to do, it's very nice study, but add in the conclusion or the discussion the technique, why you decided to do the decision trees and what alternative solutions could exist.
Okay.
Okay, because this is a point that needs to be clarified. Once you apply a machine learning technique, you have to be sure that the technique you apply is a winning horse over other techniques. Number 2, you have to decide whether it's applicable or this is a killing way that you can do it simpler. So please describe this into your discussion section. Okay, guys?
Okay, thank you.
Otherwise,
Thank you.
it's a valuable project with high merit. Thank you very much.
Thank you
Thank
so
you.
much.
Thank you.
Any other questions?
All right. Thank you all.